It's going to be awesome. But I'll need to start out with one brave volunteer, one brave soul. Oh, all right, Jen, come on up, man. Were you raising your hand? Sure, come on up. You can do it. All right. You're going to be a corn farmer.
Okay.
All right. It's very simple. It's not complicated. Come over here to the corn farming. Here's how it's going to work, you guys. This is Jensen's corn farm.
It's very small.
It's very small, right? It's his 40 acres. Use your imagination. And it fixed or variable? What do you think? Fixed, right? If he wants to make it bigger, he's got to buy more land and convince the seller. So it's fixed input. And the other thing that he has are 8 markers here, all right? And that's how he's going to produce corn. So you're going to have 20 seconds in your growing season to produce as much corn as you possibly can do. I'm going to need it. So in the 20-second time period, Jensen, you're going to grow as much corn as you possibly can by writing the word corn as many times as you possibly can within your corn growing unit. Got it? Within your farm.
With different markers, or?
Yes.
Oh.
A successful piece of corn, a USDA approved piece of corn, is written like this, legibly, in this order of color, right? Black, green. Do you tell us, give us a countdown, 3, 2, 1 or something?
3, 2, 1, go.
Oh. I got like 3.5.
Logan, how many corns do we have?
I'll call it 3. I can't see the top end, but I saw him trying to write it. It's there.
So, you guys, what we're going to do here is create a little bit of a chart, and I'm going to put in this column the variable input, and then the amount of corn that we produce over here. So, of course, if I have 0, our input being labor, right? If we have 0 units of labor, then we produce 0 units of corn, right? We can't can't do that. But with 1 unit of labor, we're able to produce 3 units of corn, right? That's our output. So what we're going to need now, what we're going to do is we're going to go into another production period, also 20 seconds. But this time we're going to have 2 farmers, right? 2 units of labor. So who would like to be our second? Not bad, not bad. All right, you guys.
Got 8 bushels.
8 bushels, nice. 8 bushels of corn. All right, there we go, excellent. So in other words, what we're measuring here, when we use 1 unit of labor, we were able to produce 3 units of corn. When we had 2 units of labor, we were able to produce 8 units of corn, right? So actually, I'm going to be a little more specific here. What we're measuring here is what we call total output, or what your book will call total product, right? Total product is just another word for the total amount we produced, or total output. And then in the third column, I'm going to make another column. This is what we're going to call marginal product. And you guys are familiar with the term marginal. Marginal means additional or incremental, right? So what we're measuring here in this third column is we're trying to measure what each additional unit of labor adds to output, right? Or adds to product. So in this case, if we started with 0, we made 0 corn. By adding Jensen, how many bushels of corn did Jensen add? 3, right? Pretty simple, right? So the marginal product of Jensen's labor was equal to 3, right? The difference between 0 and 3. When we added Riley, what's the marginal product of the second unit of labor? 5, right? 5. So we went from 3 to 8. 8 minus 3 equals 5. So the marginal product of the second unit of labor is equal to 5, right? What can we conclude? What does that tell us?
It's better to work with 2 than 1.
Yeah, I was gonna say Riley is a far better farmer than Jensen, but that's not the case, right? I actually don't know that. What'd you say,
I
Melissa?
think it's better to work with two than one.
Why?
It's more productive
Why?
because you have more people on task doing one thing.
That's it. That's it. You have people on one task, right? Adam Smith called 20 seconds, as many bushels of corn that you could produce in the time period. And Logan's gonna measure what we've got.
3, 2, 1.
19, all right, we'll go with it. That's fantastic, right? Our total output was 19 bushels of corn, right? With 3 people, we produced 19, but what was the marginal product of the third unit of labor? What did they add to the mix? What did Dakota add? 11, right? The difference between 19 and 8, right? So you can see as we add each additional unit of labor, we not only produce more corn, but our productivity increases. We produce more than the previous unit. 26, all right, we'll go with it. We got 26 units of corn, and you guys, total output 26, our marginal product. The marginal product of the fourth unit of labor is equal to? 7 is right. Yeah, 7 is right. All right, our total output is going up, but our productivity is starting to go down, right? So let's try this again. Let's get a fifth unit of labor.
3, 2, 1, go.
We'll just say, we'll give you 30. We'll give you 30, right? Just for kicks. We probably need a better rule manual or better standards, right? But we'll go with 30, and the marginal, so our total product is 30. That means the marginal product of the fifth unit of labor is equal to what? 4, right? 4, right? So you see a pattern start to emerge, right? Initially, as we began to specialize our labor in C's and O's and R's and N's, we got more productive, right? In other words, what I mean by productive is our marginal product increased, right? Not only did total product increase, but the addition of each unit of labor got better for the first and the second and the third unit of labor. Our third unit of labor was the most productive one. Wait, who was third? Not Rod. Yeah, that was Dakota, right? He was the most productive one. But once we added the fourth unit of labor, even though they added to total output went up. It went up by less than it did the previous unit, and so on. So what happened? Why did productivity begin to decline beyond the third This field of corn, it's fixed. If we could make it bigger, the scenario changes a little bit. But this is what we're stuck with, right? And if we were to continue to add more people, we'd have more, cooks in the kitchen or whatever analogy you want to use, and we'd have a real problem, right? So this is a theory in economics, a short-run theory of production that's really important. We think it's so important that we call it a law, right? When we call it a law, we really mean it, right? Like the law of demand or the law of gravity. This law is called the law of diminishing marginal returns. The law of diminishing marginal returns. You've probably heard this before. It's an economics term, but it pops up here and there. And it's the idea, really in layman's words, it's just too many cooks in the kitchen, right? And it's a short-run production phenomenon, right? That means when we have at least one fixed input, the size of our coffee shop or the size of our kitchen or the size of our field, that's our fixed input. Within that constraint, as we add more and more of a variable input, we get more crowded. And as we add more and more units of production, right, or more and more inputs of production, we don't necessarily get more and more productive, right? We face this constraint. And we think this law, that's universal, right? Every production that we look at in the short run hits this point of diminishing marginal returns, right? And so that's important to understand. We've got these two things that happen in the short run. Initially, we get more productive because we specialize resources, but that only holds true to a certain period of time, right? And so there's some insights that come from it. It helps us understand a really important question that all producers have to answer is like, what is the best mix of inputs, right? How much labor in this case do we need? So you guys tell me, what is the optimal amount of labor based on this information to employ on our corn farm?
3.
You say 3? Other ideas? 3 is definitely the most productive, but it may not be the optimal one. We'll actually get to that in the next chapter because it depends on a few things that we don't have here, right? Number 1, how much does a bushel of corn, what's the price of a bushel of corn in the marketplace? Is it $1 million or is it $1? The other thing is, how much does this labor cost, right? Does this labor work for free? Does it work for $1 an hour, or does it work for $50 an hour? Those two things we need to make sure that we understand it. So are there any circumstances, y'all, in which we would hire the 5th unit of labor?
If we had a bigger field.
Possible if we had a bigger field.
Somebody's sick.
Somebody's sick, right? Yeah, Dakota's out sick, yeah.
If the, what you can sell the marginal amount of product for exceeds the cost of labor.
Yeah, that's beautiful. That's thinking like economists. Well done, Nelson. This person is still bringing to the table 4 additional units of corn, right? So if that, let's just say the 5th unit of labor costs us 0, right? Their wage is $0. As long as that brings in more revenue than what it costs us, I'm gonna hire that 5th unit of labor, right? Now, just for giggles, let's say that their marginal product was actually -4. Would we hire them under any circumstances? No way, right? That's like that person, the McDonald's manager hires that just gets in the way and makes everything worse, right? And prevents us from actually serving employees. And that does happen, right? That does happen. So the point here, you guys, of this exercise was to demonstrate these 2 universal rules of productivity, that when we specialize resources, we become more productive. And beyond a certain point, given some fixed input, we hit this block, right? The law of diminishing marginal returns.